Thank you, dear Chairman, for giving me an opportunity to to discuss my research topic. So the topic is related to enhancing crack resistance and strength of recycled aggregate concrete with end-of-life ties steel fibers. The research motivation for it is that how we want to make our environment green and sustainable, and increasing the sustainability of construction industry, and by reducing pollution by recycling the waste and its ingredients and utilizing waste in structures. The research motivation is by using the waste steel fibers from the tires, combining it with the recycled concrete aggregates, and for producing new concrete, and to check that is it that can we replace the traditional concrete with this type of concrete, and can we get the improved properties. So there are a lot of research about in this field until now. So relating the pollutions and waste tire, it is the aspect one. So it has been predicted that by 2030 there will be up to 5 billion end-of-life tires in landfills and stockpiles globally. And Sonital reported that forecasted that 20 million megagrams of tire will be produced in China alone in 2020. And tires last up to 100 years in the open air before degrading. So, and it has been also reported by European Tire and Rubber Manufacturing Associations that out of the total waste tire, a small amount, only 3% was used for the civil engineering, public works, and backfilling. And it has been also reported that steel is used in the tires for up to 10 to 15% of lightweight vehicles, and up to 21 to 25% in heavyweight vehicles like trucks. So discarded tire steel fiber can be used as a fiber in concrete due to resemblance with the industrial steel fibers. The aspect number two is the recycled concrete. It has been reported that 75% of global constructions and demolition sites consist of concrete waste, and aggregates account for about 85% of the total construction and demolition waste generated. Sufyan et al. And other authors also reported that recycling and reusing construction waste, particularly aggregates, are therefore essential for sustainable development. Therefore, it is very crucial to examine the possibility of using waste concrete in new constructions. So the overall goal of this research is, this is tiny part of that research. This research program is to study the effectiveness of the using in-life tire steel fibers, which can also be named as the waste tire steel fibers, and recycled concrete aggregates for potential applications in the construction industries. Specific aim is specific aim of this small part of the research is the experimental evaluation of compressive properties, indirect tensile strength, and water absorptions of concrete, incorporating local inlet steel fibers and recycled concrete aggregates of Bratislava, Slovakia. And the current study is that, to the best of others' knowledge, available experimental results are insufficient to conclude the optimal dosage of in-life steel fibers, in-life tire steel fibers, and recycled concrete aggregates for particular applications in the construction industry for practical implementations. And the results related to the compressive strength properties, flex tensile strength, and water absorptions of in-life tire steel fibers and RAC incorporated concrete are reported in previous studies are minimal. So it is very important to explore a combined use of uh, recycled fibers and recycled concrete in terms of compression behaviors, flex tensile strength, and water absorption for improving the sustainability of construction industries. So in this live, the scope of the work is we use the concrete which was available. We design our mix according to C2530, and 0.6% of the fibers were used, recycled fiber, and 0.6% of the industrial steel fibers were used as a reference. And these were added by volume fractions. The locally available fibers were used by provided by fiber company, and these were the dimensions of the recycled steel fibers, and below are the dimensions of the industrial steel fibers. and in total 6 cylinders and 3 tubes are prepared for each cast for each batch. The testing procedure, STM standards were followed for each test, as mentioned, as shown here. According to results which we got, this is for the same water content. The decrease in slump for the recycled steel fiber was high as compared to the industrial steel fibers and as compared to the plain concrete. And it is worthy to mention that in this concrete, in the plain concrete, in all 3 batches of the concrete, there was 75% replacement. We replaced 75% of the national aggregates with the 75% of the recycled concrete aggregates. So here the 7R present the recycled 75% replaced national aggregates. And 0 represents 0% of the fiber, that is the plain concrete. Here the 6S present the 0.6% of the industrial steel fibers, and 6R present 0.6% of the recycled steel fibers. That is from the waste tiles. So you can see that there was a significant effect of 0.6% of the fibers of the recycled steel fibers, and the slump was decreased by 20% as compared to the plain concrete without fibers. The compression test results, we did draw stress strain curves, and from the stress strain curves, we also compare the compressive strength, and you can see there was not much significant effect on the compressive strength. And with the recycled steel fibers, this compressive strength got decreased. This is because most of the literature review in here also concluded that by using a high percentage of the fiber, almost around more than 0.5%, the compressive strength was not much improved, and also decline was reported by different authors. We also calculated the compressive properties. That was the compressive total energy and compressive toughness index, and you can see as highlighted, the industrial steel fibers show significant improvement in the compressive total energy, but also the recycled fibers show to some limit the improvement in total energy. But the toughness index for both of the fiber concrete were higher as compared to the plain concrete. By comparing the results of indirect tensile strength, we compare the split tensile strength, which is also called split tensile strength. And the industrial steel fibers improved the indirect tensile strength by 46%, while there was no significant improvement by the recycled steel fibers. That was 10%, but much better than that of the plain concrete. Water absorptions, there was somewhat decrease in water absorptions as compared to the plain concrete. And you can see here that was, and the maximum was for the industrial steel fiber for the same dosage of the concrete fibers. But also there was a minimal 3% decrease in water absorption at 0.06% of the recycled steel fibers as compared to the plain concrete. Here are some conclusions from this small pilot study. That is for the same water content, the slumps of the 6S7R, that is industrial steel fiber reinforced concrete, and that of the 6RF7R, that is the recycled fiber reinforced concrete, decreased by 12% and 20% than that of the plain concrete. And also slight reduction is noticed in the compressive strength of the fiber concrete as compared to plain concrete. Improvements are noticed in the compressive total energies of both type of the fiber concretes, and a reduction are noted in the water absorption for both of the fiber concrete as compared to the plain concrete. An enhancement of 46 and 11% is noted in the split tensile strength. So it can be concluded that the combined use of the in-life steel fibers and recycled concrete aggregate is expected to be more effective in improving the sustainability of concrete structure due to substantial improvement in tensile strength and compressive energy absorptions, and crack resistance and reduction in water absorptions. There are some small recommendations based on this study, that is evaluating the long-term performance and durability of concrete structures containing in-life steel fibers and recycled concrete aggregates for sustainable constructions. and the influence of incorporating hybrid form of discarded steel fibers, including other types of industrial steel fibers and recycled concrete aggregate incorporated concrete. Thank you. That's all from my side. And we have also published different paper related to this topic, but that is why we use the same type of the recycled tile waste fibers in the natural aggregate concrete. Thank you very much.